Hello, good afternoon. Welcome, everybody. Thanks for joining us for the ETHWarsaw Meetup. This is a very special edition. Yeah? Okay, sorry, we have some mic problems here. Yeah? We're all right? Okay. Okay, the camera. Yeah, so this is a special edition of the ETHWarsaw Meetup. I'm getting some... They can't hear me in the back. Okay, that's better. So let's start again. Welcome to the ETHWarsaw Meetup. This is a very special edition with our partners from Filecoin. So this event is going to be a part of the Orbit program. And we have two great speakers today. We have Robert Dowling from Filecoin and Joanna Słupczewska from Uniquely. And Aaron is going to kick it off with a quick intro to Filecoin. So let's give a round of applause to Aaron.
Thank you. Well, thanks everyone for being here. And just on behalf of the Filecoin Foundation, I just want to thank everyone for being here tonight. Really excited to be here in Poland. This is I guess my second time in Poland, so excited to be back. But really love the city here. Really excited to meet some of the folks from the community. And I wanted to just introduce really quick the Filecoin Orbit program. So this is our community kind of ambassadorship program that we've been rolling out over the last year, hosting lots of meetups and events like this, just community events around the world. Last year we did about 200 around the world. And we're on pace to do about that amount this year. And we're trying to expand our presence in Europe a bit more, especially as we're heading into the next cycle of the market here. And really just keen to connect with folks in the community here and find ways that we can just partner with what you guys are already doing here with the ETHWarsaw team. So excited to have you all here and excited to chat more about just ways that we can partner on things and really support the local community here. With that, I'm going to kick it over to Robert.
Okay. Let's just see. Oh, perfect. And it goes back to. Great. All right. Hello, everyone. Thanks so much for having us. First of all, thank you to Martina and the ETHWarsaw team for putting this together. How about a big round of applause? Now, I was told just before we walked in that this was a historic building and 50 people died here a few years ago or something. So hopefully we'll make it through the talk without the floor collapsing underneath us, and that would be really great. So, okay, amazing. All right, so I'm going to give a little bit of a history talk, and then we'll get into Filecoin, but we'll talk a little bit about computing and Bitcoin and Ethereum, and then I'll tell you all about Filecoin. So if that works for you guys, we can get started. Does that sound good? Okay, great. All right. This is the Moore School of Electrical Engineering at the University of Pennsylvania, and it was here in the 1940s that researchers from the Army, Navy, Harvard, and the University of Pennsylvania came together to build the first computer, which they called the ENIAC. And the goal here was to compute missile trajectories during World War II. This computer was made out of vacuum tubes, which are effectively light bulbs. When you have electricity flowing through this light bulb, you have a 1. And when you have no electricity, you have a 0. Naturally, that gives you binary digits, and from that you get binary mathematics. And this computer had about 180,000 of these vacuum tubes. It wasn't until the late 1950s that Caltech professor Richard Feynman gave a talk called Plenty of Room at the Bottom, where he questioned whether or not, at a time when people were building huge things and going to space and building spaceships, he questioned whether or not things could be built much smaller. And he put out a number of challenges. Okay, there we go. He put out a number of challenges, one of which was, can we build a car smaller than that dot on the piece of paper? Another challenge was, can we write the entire Encyclopedia Britannica on the head of a pin? And naturally, it turns out we can. And we do it through a process more or less called nanofabrication, but it's done on a special material called silicon. And now silicon is a semiconductor, and so what that means naturally is that sometimes it conducts electricity, sometimes it insulates and prevents the conduction of electricity, and you could actually manipulate that. And so what ended up being developed is something called a transistor. And this transistor is effectively a very, very small device that's built on the silicon material. And as you can see, it's effectively a voltage gate. And when you have electricity flowing through the gate, you have a 1. And when you have no electricity, you have a 0. And so what that effectively gives you is your binary digit. And again, binary mathematics. But this is much smaller than a light bulb. This is maybe 5 to 7 nanometers. At this point, we're getting down to like 3 atoms in width, which is crazy. Crazy small. So small. Sorry. This is, a little bit of a lag here. Okay. So small that on this 4-inch wafer, this is a 4-inch diameter wafer, you could fit 100 chips, and on each chip, you have 2 billion transistors. So just to give you a sense of the scale here that we're talking about, your phone has one of those chips in it, and if you were to build a computer out of vacuum tubes with the same computational power that your phone has in your pocket, you would need a building the size of the Pentagon building in Washington, D.C. in order to be able to achieve that. There is something that defines, okay, let's see. All right. There we go, okay. There's something that defines how many of these transistors we could actually fit on a 2-inch by 2-inch chip, and more or less it's called Moore's Law, so the number of transistors you could fit on a chip doubles every some number of years, and eventually we're going to hit some type of limit. What that limit might be, maybe it's 1 atom, or maybe it's 1 electron in terms of size, but now we're talking maybe quantum computing. But anyway, that is just something worth mentioning. Okay. All right. So then naturally, now we have all of these computers by the time we reach the 90s, and we want these computers to be able to talk to each other, and so the internet is introduced. And I'll come back to the internet in a little bit when we start talking about Filecoin, but for now I just want to mention one group in particular called the cypherpunks. So who here has heard of the cypherpunks? Yeah. So the cypherpunks were the first case of internet activism. Who were they? They were engineers and privacy enthusiasts who had a listserv, the first listserv on the internet, and they would send privacy manifestos to this listserv. But more or less their activism was all about getting privacy technology out to the masses so that they too, the masses, can use the internet. So they could do banking and medical records and private messaging with each other on the internet. The reason I bring them up is that many of them were involved with the earliest conversations on the Bitcoin Talk forums, and were actually speaking to Satoshi Nakamoto about the design of Bitcoin. One such cypherpunk, their name was Hal Finney, actually received the first ever Bitcoin payment from Satoshi Nakamoto. Now, unfortunately, Hal Finney suffered from ALS. He's currently cryogenically frozen, I believe. But anyway, that's that situation. Okay. Then we fast forward to 2009, and we have the financial crisis, and this is the article that is referenced in the Bitcoin Genesis block. We'll see a little later exactly how it's referenced by looking at Bitcoin's Genesis block raw hex, let's call it, description. But nonetheless, this is maybe a motivating factor for something like Bitcoin, which is our banking situation, specifically central bank money inflationary money devaluing purchasing power and people's savings. And we'll see exactly, after we talk about exactly how Bitcoin works, we'll see why we think that this is a motivation for the design of Bitcoin, specifically in the money supply of Bitcoin. Okay, so enter Bitcoin, an alternative currency. All right. And I'm just going to tell you a little bit about a few of the innovations that Bitcoin introduced. First, naturally, you're all familiar with your wallet. Your wallet is asymmetric cryptography. This is, you have a public address, which is a random string of letters and numbers that anyone can send Bitcoin to, in the same way your house's address is public and known to people that might want to send you mail. You send money or you send Bitcoin by signing for Bitcoin you want to send to someone else with the associated relevant private keys. This is another random string of letters and numbers. And more or less what makes this very interesting is that it actually changes the entire privacy model around doing financial transactions. In the traditional privacy model, which banks follow, you have the bank, which is your trusted third party, knows your identity, all of your transaction data, and does the transaction with the counterparty bank or whoever you're sending money to for you. That all happens behind a wall, and the public cannot see that information. This new privacy model that Bitcoin introduces is very interesting because everyone can see the entire history of the full Bitcoin ledger whenever they please. And in fact, all of the transaction data is public, but your public address is pseudonymous. So we don't know exactly who's transacting, but we do know, like, we can't identify you, but we could identify your Bitcoin wallet by simply looking at the blockchain. This is relevant in a little bit when we're going to talk about some crypto forensics, so keep this information in mind. So that's the first really interesting thing. The second really interesting thing about Bitcoin is that it solves a very, very important problem in computing. That problem is called the Byzantine generals problem. The Byzantine generals problem is, how do we have multiple devices that all agree to the same file at the same time? It's a very tricky problem to solve, but naturally, Bitcoin proposes a solution through its mining process. And we have thousands of Bitcoin miners all over the world who go through this process more or less to come to agreement as to what the current state of the Bitcoin transaction history is at any given time. This process, this mining process, begins with a block. A block is just a little bit of computer memory. The miner will get some proposed transactions that some Bitcoin users will send out to the network. Those transactions will wait in kind of transaction purgatory called the mempool, and they will try to gather as many of these transactions as possible and literally write them into the memory that is that block. They will then look at the blockchain and look at what the highest numbered block there is currently and label this new block, whatever that highest number is, +1, and also reference that previous highest block. And then they will do something, they will solve a nonce. So what is this nonce? This is a cryptographic puzzle. And although it sounds like the miners are actually doing something smart in solving a puzzle, this is actually a really, really dumb process. The miners are randomly generating possible solutions to this cryptographic puzzle and more or less guessing over and over again until they get the right answer. And that's where all of the electricity spend comes from in the mining process. Now, what happens next? This is the 6 steps taken right from the Bitcoin white paper. What happens next is, now that this block has been created with all the transactions included on it, the nonce is solved, it is proposed to all the other miners on the network. And if a majority of the miners agree that 1, the transactions are legitimate, and 2, the nonce solution is correct, then they will express that this is the correct block. We can start building the next one in the chain by literally building more blocks in the chain and competing to build the next block. Now, 2 things I want to highlight. First of all, Satoshi Nakamoto actually specifically defines what a Bitcoin is in the Bitcoin white paper. Does anyone know what that definition is? Yes? Okay, it's okay. Yeah, totally cool. Satoshi Nakamoto, the phrase literally is, we define a Bitcoin or a digital coin as, and then a couple of words. So does anyone remember that quote? I could just tell you. Okay, I'll just tell you. So Satoshi Nakamoto actually defines what an actual Bitcoin is. When you receive Bitcoin, you're actually receiving something of substance. And what you're receiving is what they call, quote, a chain of digital signatures. Well, what does that mean? It means that the Bitcoin you're receiving is actually the record of every private key that's signed for that Bitcoin and has previously owned it in the past until it's gotten to you. And what the miners do is they check that history, they check that Bitcoin to make sure it's never been double spent. And this is a necessary requirement to the Bitcoin design because we're only ever adding transactions. We can never remove transactions. It's the only way you could get this kind of process by which all of these miners can agree as to what the ledger is. If you start removing transactions, then obviously you're in a lot of trouble. But naturally, ensuring there's no double spend, which means someone is trying to send the same Bitcoin to two different wallets at the same time, ensuring there's no double spend is a requirement because that is actually a big problem that we had in the banking system. So what you could do, technically speaking, is from your bank account, if you have $100, let's say, you could, in the past, get away with sending that same $100 to two different people, and the bank won't catch up for multiple days, in which case, when they figure it out, they will debit your account to negative $100 because you sent the $100 twice. But naturally, from a fintech perspective, this is the same as printing money from scratch from your own bank account. So naturally, you can't have that on Bitcoin. So it's a necessary part of the design. Okay. So now we all know what Bitcoin is. There's something else I would like to highlight, which is the Bitcoin money supply. And this is maybe the most interesting chart in finance in the past 2 decades. You'll remember I told you these miners spent a bunch of electricity in order to produce a block and add transactions to the Bitcoin history. Well, they do not do this for free. They get rewarded when a block is accepted. The miner that has proposed that block gets some newly minted Bitcoin that's never been in circulation before. And naturally, you all know this because there's been a lot of discussion about a halvening event that's happened, I think, yesterday. But what is that halvening event? Okay, I'm going to guess which button is the laser, and we're gonna see if this. Okay, that is not it. All right, we don't have a laser. That's okay. So what you're looking at here, these blue lines here, first of all, let me say this. The x-axis is effectively time. This is the block height, or the number of blocks that have been created. And basically every 210,000 blocks, you could consider that every 4 years. And as you could see, every 210,000 blocks, or every 4 years, the miner's reward, which is these blue lines here, actually cuts in half. So we started in the first 4 years at 50 Bitcoin, then in the second 4 years we went down to 25, then 12.5, then 6.25, and now we're at 3 1/8 in terms of the miner's reward. Now, the effect that has on the total number of Bitcoins in the circulating supply is this red line here. So this gives a really, really interesting deflationary currency. I'll come to questions at the end. So this gives us really, really interesting deflationary currency where you actually have a maximum limit of the number of Bitcoins that will ever be in circulation, and that's because over the same periods of time, the number of Bitcoins that are being added to the circulation decrease as time goes on. So you have this red inverse log kind of money supply that has a limit of 21 million Bitcoins. And you could imagine as a miner, if you're mining Bitcoin and you're being paid 6 Bitcoin every time you mine a block, and then all of a sudden, the amount of Bitcoin you get paid goes to 3 Bitcoin, but you're spending the same amount of electricity to generate that Bitcoin, you're going to have to adjust your prices in order to continue your business. So that's all I'll say on that without speculating further on what the Bitcoin price should be. Okay. There's one more chart here. This is your Econ 101 class that you might have seen this. This is the index of central bank independence as a function, this is average inflation rate as a function of your index of central bank independence. So what this tells you is the more independent your central bank is from government control, the less inflation you usually have. But naturally, you will always have some level of positive inflation. The reason for this is that while governments like to spend money on debt, then print money and pay back their debt with highly devalued currency. And you have extreme examples of that in Zimbabwe, Venezuela, all sorts of places. So this is maybe something that Bitcoin is supposed to be an answer to in terms of its money supply. Okay, I'm going to skip that. All right. Enter Ethereum. We're here at ETHWarsaw. So many of you have already probably built on Ethereum. I'm going to go through this very quickly. But now we're in 2016. Vitalik Buterin says, hey, why don't we use blockchain for more than just transactions? Let's do it for all global commerce. And the way we're going to achieve that is by building a virtual machine on top of the blockchain that handles something called smart contracts. Smart contracts, which many of you have probably already written some Solidity yourselves. Smart contracts enable you to do any form of business logic enforced by code that you would in your normal day-to-day business operations. And I like to kind of do a comparison of Bitcoin and Ethereum because their designs actually reflect what they're intended to be used for. Specifically, Ethereum has smaller block size, but a higher speed of block approval, suggesting that we'd have a higher volume of transactions put into a smaller number of blocks, suggesting that there's an expectation, at least from the creators, that we would have this be used more or less for some type of commerce other than just simple transactions. The other interesting thing is Ethereum does not have a deflationary money supply. Up until Ethereum switched to proof of stake, which is kind of beyond the scope of this talk, I won't talk about it. But up until then, Ethereum's block reward was just 2 ETH fixed, and it had an unlimited supply. Didn't matter. That's very interesting. There is deflationary pressure on Ethereum. The deflationary pressure is there's a burning through the gas and the fees and all this stuff, but naturally there is no deflationary design beyond that in the same way we have for Bitcoin. The other comparison I like to look at is the difference between how Bitcoin and Ethereum accounts work. So who in the audience has heard of unspent transaction output? Okay, maybe a few of us. Unspent transaction output is how Bitcoin accounts really work under the hood. Ethereum is simply accounts the same way you would use on Cash App or Venmo. So maybe I can explain how unspent transaction output works with a simple example. The example is this. You want to go buy a sandwich. You only have $20 US, let's say, and the sandwich costs $14 US. when you go to buy the sandwich, what is practically happening is you are handing the vendor, the person selling the sandwich, an account worth $20 US when you hand them the cash. And the vendor is going to break that $20 US into two new accounts, one worth $14 US and one worth $6 US. The $6 US is a change account. The vendor will keep the $14 US account, and the vendor will return to you the change account worth $6 US. That is exactly how unspent transaction outputs work on Bitcoin. So whenever you send Bitcoin, let's say you want to send your friend 3 Bitcoin, but your Bitcoin wallet only has a 5 Bitcoin unspent transaction output associated with it. What's actually going to happen is the Bitcoin software will send the 5 Bitcoin unspent transaction output to your friend, and more or less the software will break it into 2 accounts, one worth 3 Bitcoin, which is what you want to send to your friend, the other worth 2 Bitcoin, which is a change account, and the change account will come and be returned to you. That's very different from the account model on Ethereum. On Ethereum, the account model is simply you send some Ethereum, it updates the state of the Ethereum state machine. So this is more or less a much simpler, elegant maybe way to do it, but with unspent transaction output, this actually reveals something to you forensically. You could imagine if you look at someone's transaction and you want to determine how much they actually paid for something, well, if you look at the decimal places of the 2 unspent transaction outputs, one being the actual amount spent and the other being the change account is much more likely to be 8 digits of random numbers, and the money being spent for the actual payment is much more likely to have trailing zeros. And the reason for that is people send clean amounts of money to each other usually. So that's a really interesting phenomena that has led to some very interesting Bitcoin forensic work. All right, proof of work versus proof of stake. I think you guys would already know all about this, so I'm just going to skip it, but Ethereum has switched to proof of stake. And finally, these smart contracts give us a lot of really, really interesting use cases. You're all familiar with NFTs and ICOs, but what I really like about this is that in the same way, you'll remember we talked about your Bitcoin public address being available to the public with all the transactions being available to the public. Well, okay. This is, okay. This is a video. I don't know if we could play a video, but okay, let's assume we can't. This is good enough. I guess we can we? That'd be great, yeah. You'll see. Maybe you could, I don't know, maybe Solana happened after this, but yeah. Perfect. Oh, it's okay. What happens if you just press that right here? It's not working. Oh, it did? Oh, great. Okay, it's no problem. Cool. Okay, no problem. Anyway, this video, these circles get bigger over time because this actually traces all of the ICO fundraisers that were happening. Why is that, or how is that possible? Well, when someone does an initial coin offering on Ethereum, what they're actually doing is publishing the address of a smart contract. And the smart contract basically says, hey, you send from your wallet on Ethereum some ETH to this smart contract address, and the smart contract will send back some newly minted tokens that we've just created out of thin air. And so because the smart contract address and everyone else's public addresses are public and that transaction data is available, we can actually see how much ETH was raised by writing some nice program that actually demonstrates this for us. So this is from a company called Elementus. They're a great data science company out of New York, and I really like this visualization. And maybe you can watch the video later. It's on YouTube. But naturally, yeah, that's really cool. Anyway. The other thing that is very, very interesting about, first of all, being able to do business logic on Ethereum, but also that's possible because of the open and transparent but anonymous nature of all of the wallet addresses, is you can do some forensics to determine whether or not certain transaction patterns are revealing something to you about the business practices of a given business. So what do I mean by this? Here's an example of an ICO. It's called Car Taxi. So in 2017, this is a business that, it's almost ridiculous to say, but this is a business that has a bunch of tow trucks, and they go to the Trans-Siberian Highway, and whenever cars break down, they pick up the cars. Now, why this company would ever need an ICO, let alone $7 million, makes absolutely no sense at all, but nonetheless, this is what they claim on their Medium, that they've raised $7 million worth of ETH through their ICO. This is that is from their Medium. And the good news for us is we can identify some of their wallets on the blockchain. How can we do that? Well, first of all, we know that from their Twitter, they're announcing their ICO smart contract address. And so right off the bat, we have the first round of the smart contract address for Car Taxi right here. That's what this red dot represents. All of these blue dots represent the third-party wallets that have sent Ethereum to this smart contract address. We know that simply by looking at all the transactions that have gone to the smart contract address. And then this wallet right here, we know is the Car Taxi Ethereum wallet address. How do we know that? Well, Car Taxi announced that this is their smart contract, ICO. Where else would the ICO send all the ETH that was raised? Only to the wallet associated with that company. So even though that wallet is an anonymous string of letters and numbers, we now know that's the Car Taxi wallet. And as you can see here, they did a second round of an ICO where you still have these third-party wallet addresses sending ETH to the smart contract, but you also have a very interesting pattern, which is there is some ETH coming from the Car Taxi wallet into the smart contract address. Now, why would that happen? Well, who knows, but maybe it's an indicator of the punchline here. It turns out only $2 million was raised in this ICO from third-party Ethereum addresses, and the other $5 million was actually refunneled through by Car Taxi themselves. So what type of fraud is this? I don't know. Maybe it's like a FOMO fraud where they're trying to make their ICO look a lot more impressive than it really is, to try to trick some investors into giving them money. But nonetheless, what they've announced is inaccurate. So even though it is true $7 million went into the ICO, only $2 million of it came from third-party wallet addresses. So that's kind of some of the cool data science you could do on Ethereum. All right, and finally, I told you that in the Bitcoin Genesis block, it references the article from the Times about the bailing out of the banks. This actually reveals some other interesting data science we could do with Bitcoin, and that's that we can label all of the Bitcoins in existence. Now, you might say, Robert, why would you want to label any Bitcoin? Well, maybe you're a coin collector, and you might want to start collecting Bitcoins. And there might be certain Bitcoins that are important to you. For example, maybe you want to own a Bitcoin that Satoshi Nakamoto once owned. Or maybe your favorite number is 17, so you want to own Bitcoin that was specifically put into circulation on the 17th of March for whatever reason. And so this is called inscriptions and ordinals, and it's a very interesting new phenomenon on Bitcoin that I would encourage all of you to look out for. Okay. Now that we got all of the background information in, maybe we'll talk about Filecoin now. So I'm going to begin talking about Filecoin by talking about the internet, as I promised I would earlier. As you guys know, with the internet, data is transferred via the internet protocol, or your IP addresses. What is your IP address? It's actually a geographic location. And so when you transfer any information, your IP address actually tells you nothing about the data that's being transferred. So this is not a very useful mechanism for transferring data over the internet. Luckily, we have a solution already tried and tested for how we might build an alternative. And that solution is your ISBN system at a library. So in the ISBN system, you have a unique identifier for every book that has ever been published. And that unique identifier, okay. By the way, really loving the TV back here. It's really been helpful. So anyway, you guys can't see it, but it's helpful for me. Anyway, with this ISBN system, your book ISBN number will actually tell you information about what the content of the book is, whether it's the genre or any sort of other information. Data that's stored on Filecoin and the Interplanetary file system both work just like the ISBN system. When a file is uploaded, it is put through a hashing algorithm, and that hashing algorithm produces a unique content identifier for that file. If you upload a second copy of the exact same file, the hashing algorithm will produce the exact same content identifier. If you make even the slightest change, the content identifier will actually end up changing. So right off the bat, we get a very, very interesting use case out of data stored on Filecoin or IPFS. And that's data accuracy or verifiability. Starling Lab out of Stanford University is a group of, let's call them activists, academics, engineers. They go to war zones like those in Bosnia and Ukraine. They take photographic evidence of war crimes that have been committed, and then they upload this war crime photography to Filecoin, and then they create a dossier, and they submit that dossier to the International Criminal Court. Now, the reason they would want to put this on Filecoin is that once it's on Filecoin, these photos have content addresses. So if anyone tries to tamper with the evidence, the content address will end up changing. So when they submit the dossier to the International Criminal Court, there is more or less confidence that the evidence has not been tampered with. And naturally, there is another cryptographic tool they use that when they take the photo, it provides evidence that they were in that geographic location at that time when they uploaded that photo. But nonetheless, this is one very interesting use case for this content addressing. Now you might say, Robert, that's really cool. So you've told me that all of the files on both Filecoin and the Interplanetary file system have these unique content addresses. But how do you know what file you need to get, and how is it organized? Well, we organize files on both of these platforms in the same way you would organize files on your computer. And it's basically a subtree of folders, something like this. But we do it with a graphical representation. So who here studied computer science in school? Okay, you probably took a very miserable sophomore year class called Mathematical Foundations for Computer Science. And you probably are familiar with some graph theory? Yeah, maybe? Yes? Okay. Very briefly, in graph theory, we have two elements. The first is a node, which just represents a thing, and the second is an edge, which represents the relationship between two nodes. And more or less, with these content identifiers, what we have is more or less our folders and our files, and each of these is represented by a content address, and then we also have edges that are content addresses on Filecoin and IPFS that represent the relationship between these folders and files. So we can get something that looks like something sane that we could parse through. The actual style of data structure that this is actually called a directed acyclic graph. What does that mean? Well, it's directed because the edges have direction, which tell us about the relationship between the nodes. So in this case, this directed edge that points from this folder to this file tells us that this file is in that folder. It is acyclic because there's no path you could take that will let you get from one node down to another node and then back to the node you started from. There's very specific reasons for that. Mostly, it is to prevent a situation where you have folder A in folder B and also folder B in folder A at the same time. That would make absolutely no sense. And finally, you get a bunch of very, very interesting features that make it very easy to more or less parse through the information and actually retrieve it later. So the 4 features that this enables, this data structure enables, is distributability. So anyone who has a given graph of content addresses are able to act as a file provider for those files that are in that DAG. These DAGs are recursive, so you could put smaller DAGs being directed acyclic graphs. You could put smaller DAGs into larger ones and retrieve only the smaller ones later. They are verifiable because of their content addresses. So let's say you go to Filecoin or IPFS and say, I need the file that is located at this content address. Can you retrieve it for me? Someone sends you that file. You can actually verify that you got the right file by recomputing the content address with the file that has been given to you and making sure that it is the correct content address. And finally, deduplication, which, frankly, probably not as important, but I think it makes for a very, very cool, compelling visualization where if you have a content address of a given file or folder that is shared between 2 other folders, those 2 other folders can actually point to the one content address for the one file on the data structure, which makes it easier to parse through and more efficient to parse through. So that's maybe just totally just a nice visualization thing to have. And I don't know, the real consequence of that is just reducing the number of computes you need to actually get that data. But nonetheless, that is what it is. Okay. Now, I told you, by the way, this whole data structure of this graph of content addresses that I've just described to you, we call this interplanetary linked data. And it's actually a data standard that both the Interplanetary File System and Filecoin and a number of other platforms like libp2p are compliant to. So all the data on both IPFS and Filecoin are compliant to this data standard. Okay, now, I've been talking about Filecoin and IPFS. Who here is familiar with IPFS? Okay, quite a few of you, because you probably used it in a hackathon. Many, many people come to me at hackathons and say, hey, Robert, I built on Filecoin. Look, I stored some stuff in IPFS. I need to make clear that IPFS and Filecoin are 2 completely separate and different networks. What's the difference? Well, I just explained to you that they're both compliant to the exact type of data storage standard that I just described to you. So all the files on both IPFS and Filecoin are content addressed. However, they're 2 totally different networks. On IPFS, you have a whole bunch of community nodes that are allowing you to store data on IPFS out of the goodness of their heart. No one is paying them to do this, and at any time, those nodes could go offline without warning. So there's no incentive for any level of permanence on that data storage with IPFS. That's why Filecoin was introduced. Filecoin is the data and retrieval marketplace that financially incentivizes storage for a decentralized storage network similar to IPFS, But naturally, we now have a mechanism by which people can pay to have their storage maintained over a longer period of time with some level of guarantee. That is the main difference between IPFS and Filecoin. And the way Filecoin works is as follows. We have all of these thousands of storage providers, one of whom is in the room here today. We met him earlier. Hello. And the storage provider, more or less, is a data center. And they are operating the Filecoin blockchain. And the way this works is quite like this. A client, someone who wants to store data on Filecoin, so this is someone who wants to store data, will come to the Filecoin network and say, I have this much data I want to store it for this length of time, and this is how much Filecoin I'm willing to pay. And then a storage provider will see that, it's called a deal, all that information together is called a deal, and the storage provider will say, hey, I want to accept that deal because I think that's a good price, and I have data available on my data center. So the providers, the storage providers, will take the next step of signaling that they want to accept the deal by providing a cryptographic proof of replication. This is a type of proof of stake. More or less, it's a cryptographic evidence that the storage provider has taken the data in the deal and actually stored it in their data center. And then, over the course of the deal, these deals are time limited, but over the course of the deal, every day the storage provider will provide another type of proof, which is another type of proof of stake, called proof of space-time. And the proof of space-time is cryptographic evidence that the data is still in the storage provider's data center at the physical location in the data center that they promised it would be at that time. The storage provider provides that every day. And every day that this proof of space-time is provided, the client who's having their data stored pays a little bit more of the Filecoin they promised to pay in rent for that space. And if they fail to provide the proof of space-time, the Filecoin miner actually gets Filecoin slashed from their wallet. So there's a heavy incentive for the Filecoin storage provider to behave appropriately and be good stewards of the data stored on Filecoin. And then naturally, these deals are time limited, so at the end of the deal, the client will decide whether or not to renew the deal if the price is right or move to another storage provider. Okay, there's currently 25 exabytes of capacity available on Filecoin, which I know both to you and me is a word that has no meaning. So what that really means is there's 29 billion gigabytes of capacity available on Filecoin for storage, but only 2 million gigabytes are being actually stored, which is interesting. So we have more capacity than we have storage at the moment. Except, you know what, I think, now that I think about it, I don't know if that data is correct. I need to come back to that. Okay, just ignore what I just said about that. Just off the top of my head, realizing all the talks I've heard about Filecoin, I think my calculation is off. So please ignore that number. Anyway, so that was my slide. This slide is not mine. This is my colleague Paul's. But naturally, this is a slide about the price of storing on Filecoin. And more or less, you could compare it with the centralized cloud providers, excuse me, and some of the other decentralized storage offerings. And excuse me. Oh, sorry. Oh, yes. I'm recovering from an illness from last week, so I apologize. But anyway, so you could see the Filecoin storage happens to be cheaper as a consequence of the retrieval fees being cheaper. And then this was the second slide my colleague gave me showing all the prices for everyone is actually cheaper than we showed here. So I don't quite know what to make of that, actually. I think these are the real numbers. But naturally, you could still see how Filecoin storage pricing compares. And you could see the centralized cloud providers kind of get you on those retrieval fees. Okay. Cool. So that's all about Filecoin. What? Yeah, that's a good idea. Much better. So that's all about Filecoin. And I just want to tell you a little bit here about Filecoin Plus. So this is another layer on top of Filecoin. These are volunteer notaries that will actually verify that the data being stored on Filecoin is useful data. And if a storage provider accepts a notarized storage deal, what happens is more or less their miner's reward is actually 10x'd. So this is really interesting. It's incentivized naturally for 99% of all storage deals on Filecoin to be Filecoin Plus deals. And if you go to the Starboard Network Health Dashboard, you can actually see when Filecoin Plus was introduced, the split between Filecoin Plus deals going up and regular Filecoin deals going down. Filecoin also has smart contracts. So we do have a Filecoin virtual machine that enables smart contracts and on-chain programmability for the Filecoin network. It leads to many interesting use cases that are only possible because Filecoin has storage primitives that other blockchains do not have. One example is this perpetual storage example. So you could think of this app more or less as an example. Here's how the business logic would work for perpetual storage. First of all, I told you that those Filecoin storage deals, you'll remember, are time limited. However, there might be some data that you want to store for a longer period of time than maybe 1 or 2 or even 3, maybe 10, 20 Filecoin storage deal cycles. So maybe we'll write a smart contract, and this will be the business logic of the smart contract. Step 1, endow the smart contract with an endowment of Filecoin. Step 2, invest that Filecoin somewhere, who knows where. Let's just assume, for the sake of this example, that investment generates a reasonable return of some kind. Step 3 is monitor the status of the storage deal that you're interested in. And then step 4 would be, if last year my investment made more money than it would cost next year for us to pay for the storage deal, then renew the deal automatically. If not, find a new storage provider. So this is an example of perpetual storage app that could be built on Filecoin if you want to come to a hackathon and build on Filecoin. Naturally, we might want file access controls. So you might have a data set that you only want certain people to be able to access on with their Filecoin wallet. So you could permission, using smart contracts, only certain Filecoin public addresses to access that data set, and then they would get to access the data set by signing with their private key to be able to access it. Data DAOs, I'm just going to skip, but naturally you can have some type of governance around a data set. You might imagine a group of academics who have some financial interest in one data set, and maybe they have an agreement as to who should be paid out when someone pays to access that data set, and the smart contract can automatically do those payments when people pay the smart contract to access it. But anyway, naturally, many unique use cases that could be built with smart contracts on Filecoin. This is a very interesting visualization I like to show. It's from my colleague Sarah Tiem at Protocol Labs. This is for a hacker to decide if they're building if you're building an app that requires some type of decentralized storage, how do I decide whether or not I need to use smart contracts for that storage? The first question is, do you need some business logic to decide how this storage is managed? If the answer is no, you can just directly store your data on Filecoin. If the answer is yes, then you need to decide, hey, is my data a large amount or a small amount? It seems trivial, but the reason this question needs to be asked is that the fundamental unit of data on Filecoin is actually 32 gigabytes. So a storage provider, it's called a sector. It's 32 gigabytes. So more or less a storage provider wants a full sector every time someone stores data with them. so that they're making the most use of their data center space. So if you don't have 32 gigabytes of data that you need to store at any given time, you might need to do something called aggregation, where you will include, you could do it through something called Lighthouse Storage. It's a useful tool to do aggregation, and more or less your data will be aggregated with a bunch of other people's small amounts of data until you fill up a sector and a storage provider can accept that sector. And then you could go on and build your tooling. Okay. And naturally, everything I've just described, this smart contract business logic, it's actually something called computation over state, because we're doing computation about the, more or less the metadata about the data that's being stored on Filecoin. We will also in the future eventually get to computation over data. This computation over data is kind of your AI machine learning jobs that you might be familiar with, and the project that's working on that is called Bacalao, so I would encourage you to check that out. They have an interesting app called LilyPad, Water Lily, one of those two, or maybe both. And then finally, there's Saturn, which is a content delivery network built on top of Filecoin. So this enables fast retrievals of Filecoin data, and it should enable, for the first time, as it was explained to me, a video streaming over a decentralized network, which is really, really cool. Okay, there's one more thing I should mention, which is interplanetary consensus. I don't have a slide for it, but this is the new scaling solution that Protocol Labs has come up with. Naturally, Filecoin, some third-party developers have used interplanetary consensus on Filecoin to design a scaling solution for them that settles to Filecoin, but more or less, what is interplanetary consensus? This is a scaling solution that deals with subnets. So you can imagine your main blockchain like Filecoin to be your parent blockchain. And again, graph theory, you have child subnets, which are their own blockchains with their own consensus rules, where a bunch of transactions will happen using Filecoin locked on wallets that Filecoin has been sent down to the child subnet. All the transactions will happen, and then they will checkpoint back to the parent chain, and those accounts will be settled later. Okay, with that, that's all I have to say. Thank you so much for having us. That is all about Filecoin and a bunch of other great platforms like Bitcoin and Ethereum. I encourage you to reach out to me on Telegram and to come to a hackathon. So if you're someone who likes to build at hackathons, we constantly have bounties available to build on Filecoin at a number of hackathons. Many of these hackathons actually are remote. So over the course of a month, you build from wherever you are and submit work at your own pace, submit from wherever you are, and hopefully win a bounty. Okay, thank you. That's it.
Thank you so much, Robert. That was a very, very exhaustive intro to Filecoin, and I really enjoyed your presentation. Thanks again. Do we have any questions from the audience to Robert? If you want to know anything more about Filecoin, this is the moment to ask, or you can find Robert just hanging around here.
I can take a question. Unless no one has a question. Okay, we have a question here.
Okay.
Okay.
Pass the mic.
Hello, my name is Arthur. Thank you for the presentation. So about the retrieval of the data and proof of the space and time, right? When the file provider cannot retrieve the data and cannot sign the proof, and they get slashed, right? And will the like people that store this data get some Filecoin back, or what is the, like, where is this Filecoin, slashed Filecoins go?
Yeah, just. Okay, I'll just answer very rapidly. The slash Filecoin is simply burned, and this actually raises a very good point, which is if you're a client and you're storing on Filecoin, it might be wise for you to have some redundancy if the data is sensitive. So you might want to store with multiple storage providers. As an example, in case one goes offline due to a freak accident, something like this. So it all depends on how important your data is to you and how you might want to deal with that. So, yeah, cool. Any other questions?
First of all, you kind of surprised me. You mentioned the Filecoin is not on top of IPFS. So
Yeah, it's very surprising.
I still can show you a lot of articles that they literally show that Filecoin is built on top of this and so on and so forth. So, yeah, but it's like it's written everywhere. So I'm just saying that was. I mean, fake news. You know, mainly, you know, like it's the Biden people, so it's just like spread fake news outside. But aside from that, also, not to go to semantics, but would you consider going with the proof of stake other than proof of work, considering what happened, especially for the past few years, of like with the, you know, with that lack of attention to a lot of people that they thought they will go too deep on this, and then later, because the reward was not good enough, they kind of just back off.
Filecoin is proof of stake. There is no proof of work for Filecoin. The two types of proofs that you saw, proof of replication and proof of space-time, is proof of stake. So this is not proof of work. Now, if your question is, should Bitcoin go to proof of stake, or I see. Okay. I can't comment on DeFi solutions, so sorry. But happy to talk offline. So, cool. Okay. Yes. Maybe one more. Okay, one more. Yes.
Hey, so how do you solve an issue of some illegal content put to the Filecoin? Like, I don't know, a child porn, right? And then how do you, can you report it to a storage provider, or have you thought about such issues?
Well, I don't think about those issues, but naturally we have the Filecoin Plus program, and the Filecoin Plus program basically involves third-party volunteer notaries to inspect and review the data that's being onboarded to Filecoin, and if it's considered useful data, then the storage provider gets a 10x on the miner's reward that they earn. So at this point, 99% of all deals done on Filecoin are Filecoin Plus deals, which means the majority of the data stored on Filecoin is being inspected by the third-party notaries, which means that this type of material, I would say, is unlikely to be involved. But I don't know the answer to that question, really, because I just don't know. Who knows? But that sounds like an issue, some type of matter that would be handled in local jurisdictions, as would anything else on the internet. So I don't see any difference between how it's handled. So, cool. Okay, thank you so much.
Thanks again, Robert. I wanted to take the moment to thank our partners, Bitcoin.pl, PKO Bank Polski, which provided this beautiful space, and the screens with the special Filecoin mermaid tonight, and Uniquely. And we actually have a speaker from Uniquely tonight. Joanna will tell us about the NFT revolution. So let's give a round of applause to Joanna.
Hi, thank you. Nice to meet you, to everyone who doesn't know me yet, as the crypto world in Poland is quite small, so most of you we already know each other. If you don't, my name is Joanna, and I work at Uniquely as a growth manager, and I came with a really quick presentation about what we do at Uniquely and about the NFTs for the Web2 users, which is gonna be pretty easy. You do not need to be into blockchain and crypto to actually understand what I'm gonna speak about. I'm going to tell you something more about the NFT usage within the marketing field, within the user interaction, and the widespread Web3 adoption and its impact on the real world problems. So I hope it's gonna be quite easy to comprehend. I just need to grab the pilot. So here's a small agenda of what I'm gonna talk about. I'm going to start with how actually Uniquely emerged as a company, as we started from the field of fashion. Then I'm gonna tell you something more about the connection between NFTs and NFCs, about the new tech within the NFTs and the possibilities that it gives. I'm gonna show you some case studies and how it actually can benefit the normal users and the companies as well. So stay tuned. So first, Uniquely has been funded 3 years ago because we actually saw a small hole in the market and a space to develop in terms of NFTs and fashion, as we were focused on fashion since our very beginning. And now we're just spreading our wings to the other market ranges. So how did we start? We decided that fast fashion is quite boring and nobody actually wants to buy it anymore. Like if it comes to young people, we saw that people value more the unique pieces and the pieces that actually have some history to them. So we wanted to really highlight that with the NFTs and NFCs and show you how the clothes actually, how many benefits they can bring. So if you look at many industries that exist, like transportation or the silicon chips that were mentioned, like all the, like many types of markets were growing pretty quickly, and the changes were coming. And if it comes to fashion, like I'm still wearing the clothes that people would probably wear like 100 years ago. Nothing's really changing. If you look at transportations, like people used to ride horses, then the wheel was invented, then the bikes, then cars, airplanes, and so on. If you look at the chips were getting smaller and smaller, and the clothes, no change. So we decided to change it. And we decided to change it with the NFC chips. And on the bucket hat right here, you can see the NFC tag that you can also see on caps of some of our friends who are wearing the blue caps. They have the same chips associated with their clothes. And we decided to digitalize the clothing. How we did that? We simply encoded the NFC tags. We sewed them to the clothing, and we decided to create the digital representatives of the physical products. So you could own the product both physically and digitally. So each of our products contains an NFC tag encoded with a customizable landing page. So once you tap the phone to it, it opens a landing page. And actually any phone can read that. Like from now on, all the phones contain an NFC reader inside of them. So you simply tap the phone to the clothing and something happens. And a lot of things might happen. And the NFC technology, I'm pretty sure that most of you are similar with that, because the same technology that you use in your Apple wallets, it works the same with opening the content from the NFC tag. So you simply tap the phone to your clothing and it does something. And what it does, we started with digitalizing the clothing from creating the 3D models of the clothing some description of the clothing, and then the possibility of minting the NFT of that. So if you're the first person to tap the phone to the piece of clothing, you simply provide your email address and a nickname, and you become an owner of the item, not only in the physical world, but in the digital world as well. But that's just the beginning, and that's how we started. We now felt that there are many, many possibilities to the general market, like the marketing agencies and the brands themselves that we can use, and I'm gonna develop that further on the next slides. So first, we've got a lot of benefits to that, and the NFTs are just the beginning. We have the full proof of authenticity, which is the main context in which the NFTs were used in the clothing. As you know, the counterfeits are widespread, and we wanted to prevent that. So we started to use the DNA tags, which actually protect the clothing from being counterfeited. So first, we get the piece of clothing, which, for example, is produced by a well-known brand. We authenticate it with the NFC tag, and we lock it on the DNA tag, which is highly protected, so nobody can copy the content of that and replicate that. Then we have the proof of ownership, which is the NFT itself, that once you mint the NFT out of the real product, then it stays on the blockchain, so you can see the whole history of the owners who own the clothing. You can bring the items to the digital world, the metaverses. Like, I'm not sure how many of you actually use the metaverse, like the metaverse games like the Decentraland, Sandbox, Ready Player Me, but all the pieces of clothing are possible to bring to these games as well. I'm not sure what plans Mark Zuckerberg has, but if he creates his own metaverse, then we might also bring our clothing to his metaverse. And then you have a whole bunch of possibilities to entertain the people who own the pieces with the NFC tag. Like, the content on the landing pages can be edited on the go. So imagine that somebody buys a t-shirt from you, and then you tell them to scan it every couple of weeks, and they get a surprise. Like, they scan it next Monday, they get a discount of 10%. They scan it like the next day, they are getting to know about an upcoming event. So you can create like small circles of people with the loyalty programs, and you can really use it in many, many ways, and the only thing that might stop you from that is kind of your imagination. So what other possibilities of using the NFC and NFT are? Mainly, right now we're focusing on the events. So if I look at me, when I go to an event, I buy tickets on like Eventim, Ticketmaster, Going, everywhere, and then like a week before the event or a concert, I'm getting kind of stressed that I will not find a ticket on my email. I don't know who I bought it from, where it is. I'm looking for some QR codes, and then I cannot find it, and I've got a problem. So imagine if you do not need to look for the QR code on your email anymore. You simply get a t-shirt that is your ticket to a concert. And we already did that. We did a collaboration with Romanian football representation and Puma. So we did a limited collection of t-shirts. So everybody from like the VIP area who wanted to watch the match, they bought a t-shirt instead of a ticket, and they simply came to security. They showed them the tag, the security tapped the phone to the clothes, and they were getting in the match. And we were also entertaining people before the match and after the match. So before the match, you could see the counter that was counting the days and hours to the match. You could see the location of the event. So all the information were just inside of your t-shirt. And then after the match, you know, you could see the result of the match, who scored which goal, and so on. So that's just a case of matches, but the possibilities are countless. What else we've got? You could also share your socials with the piece of clothing that you're wearing. Imagine that you're right now on the event in here, and you met someone and you want to share your contact with them. So, you know, you start to spell your Instagram or Twitter username or your phone number, And you do not need to do that anymore because you can simply edit the data that you have encoded on your item page and have your socials in there. So you simply come up to some person that you like, tell them to tap the phone to your t-shirt, and then they have all your contacts saved in their phones. So that's pretty easy, entertaining, fun, and personally, I do that. Then you can, I mentioned before, checking product authenticity, and that's all within a tap of a phone because all of the phones have the NFC readers inside already. And we are not the only company that does it. It's a widespread trend, but a lot of companies actually do that, but they do that wrong. I can mention Ralph Lauren, as I see a lot of people in here wearing Ralph Lauren shirts. Ralph Lauren launched a couple of collections that had a QR code inside their labels, which after being scanned, they led to empty pages. So something didn't work there. They tried to launch something similar that we do, but it didn't work. And some brands also do some technical mistakes that prove that they want to use that technology and that they are interested in that, but they cannot fully do that. And the example can be PKO in here. Some of the girls might know it. PKO as a brand, it's like not luxurious, not like fast fashion. It's like a mid-brand with mainly bags and belts. And they launched NFC tags to all the pieces that they were selling. So I got interested in that, and I went to a PKO store, and I told the lady at the cashier desk that I would like to see the NFC bags myself. So she handed me the bag, I tapped my phone to the NFC tag, and it led me to the main PKO site. And I thought, like, what kind of authentication is that? Because I myself, I'm not such a technical person. I could replicate that myself. I could get a counterfeit bag from Alibaba, AliExpress, or so on, take the tag from the internet, and I have them like at my home. I've got a lot of them. Download any application to encode the NFC tags from App Store, and simply encode the PKO site that is available for the wide audience on the internet anyways. So people try, but they do not always succeed. And we've got some real-world cases with entertaining the customers as well. Recently, we did a collaboration with VidCats and Yohji Yamamoto, which is the brand owned by Adidas. And you can just cross a couple of streets and see that live on the 3rd floor of VidCats. So we digitalized a couple of pieces of their clothing. I hope the video will load. Yeah. So basically, this is the content that we showed after scanning the NFC tag from the clothes on the mannequins. And what purpose did it have? We had a couple of mannequins with Yohji Yamamoto clothing on the store, and we wanted to show the clients that the clothes do not only need to be physical. And how did it help the people? Imagine that you come to the store, you see a nice piece of clothing on the hanger, but they do not have your size. So you simply tap the phone to that. You do not need to search for that on the internet. You do a couple of clicks and you order it to the store. I don't know if you saw that. I can maybe go back to the video again. You have some styling inspo and you can buy the whole outfit just with a tap of the phone. So that's a huge time saver. And it gives you like a lot of possibilities. We did a basic thing in here, but on the landing page you can include anything you want. The next case was with authentication of sneakers. You remember I mentioned the PKO case, that the huge brand encoded the NFC tags with unprotected links. You can see that we have a feature to encode the protected links, so you can see the warning in here. So imagine that I have an NFC tag on my shirt. I tap the phone to that, it opens a landing page, and I want to replicate that. So I simply copy the link from the browser, have another NFC tag, and code it on another NFC tag, and just replicate the content. So we developed a tag to log the tags. So if you open the link from any other source than the NFC tag originally attached to the piece, then it's a sign that it's counterfeited. So that's kind of a product protection. And we've also got the events case. As you can see, we can do anything. We lately on the NFT Paris event, we did wristbands for W3F3 with the wristbands. So each wristband was the NFT as well, and it allowed you to enter the event just with that on hand. So you did not need to remember about anything. You could also store data or gather data about the people who got the wristbands. So as we know, data about people or customers is quite important. So now we know how you can entertain the audience or give some benefits to the community or the clients that you have, but you also can see a lot of benefits for the companies themselves. For example, we can implement the on-demand and just-in-time production. So for example, imagine launching an e-commerce store when you sell only the digital version of any products that you are going to produce later. So you initially do some kind of pre-sale where you sell the NFTs. So the people, your clients already have the digital representatives of the products. So as you observe the trends of selling the NFTs, then you can predict how many pieces you actually need to produce. So you save time, you save money, and you save up the space in the magazines that you would use later to actually store the products that you're gonna sell later. And you might say, isn't this too difficult for the Web2 user, for like a normal person? I would say no, because we also, when we were developing such kind of technology, we were thinking like, who actually knows what NFTs are, who's interested in that, and who would like to actually mint the NFTs if they do not have any wallets created, they don't know what MetaMask is, how to do that. So we tried to make it really easy to let the people mint the products just with their nickname and email. So the only thing they need to do to mint the NFT is to provide their nickname and email, click mint the NFT, and the NFT is already being minted on a custodial wallet that we create for them. They do not even need to be aware of that, so they get the account created just with the nickname and email, which everybody can come up with, and they already have a wallet, and whenever they're ready, they can simply connect their MetaMask and transfer the NFT from the custodial wallet to their MetaMask, and they would be the digital owner of the item. So that's kind of easy, and everybody can do that, and that's why I think maybe not the revolution is coming, but a huge change is coming, and we simply want to make the NFTs more easy to comprehend for the real-world users. And if we look at the future, these are just, like, the market is so small right now for the NFTs, but it's growing, and I see it from my own experience. I remember myself 2 years ago starting within the field, and I come from the fashion industry, and all my clients that I knew from my experience were quite resistant to that, and now everybody's up for that. And you might say that NFTs are dead. Maybe they are, if it comes to the JPEGs that used to be overpriced and overhyped. But if it comes to the usability of the NFTs, I think the bright future is coming, and we, as the world itself, will come with many, many ideas on how we can actually utilize it, because the potential for me is quite big. I mentioned a couple of ideas on how we can use them and what benefits they can bring, but I also see many other possibilities, like imagine that you could purchase the products directly from the hangers. You go to a store, you just tap the phone to the piece of clothing that you like, and you simply complete the transaction with your phone, which unlocks the NFC tag, so you can just, you know, get out of the store without turning on the alarm. and already be the digital owner of the piece as well. You could resell the valuable vintage pieces that already would have the item history on that. I don't know if you know what's happening with, for example, the prices of Chanel bags, but they doubled or even tripled in prices within the last year. So imagine like 50 years from now, if the bags had the NFC tag attached and the NFT, you know, once you tap the phone to the NFC tag, you could see the whole item is history and you would know who owned that before you, then the value of the bag could significantly change. And other things, like you could protect your copyrights with authenticating any product that you have. Like, for example, artists, they could simply create NFTs out of the art and, you know, permanently inserting the NFC tag to the pieces that they create. The possibilities are endless, and I'm still really curious what will happen next. And that's everything that I wanted to tell you. So if you have any questions to me, feel free to hit me up. If you'd like to discuss it later, I'll be running around in here, so you could simply come up to me and we can speak about this topic or any other that you'd like to come up with.
Yeah, thank you for the presentation. It was really cool. But I think that when we talk about blockchain, cryptocurrency, and NFT, we talk about digitalization of data. But in this case, I see that we turn around and go to the move data from digital sphere to the physical sphere. So in this case, I have a question to you. Do you really believe in this technology? And if your answer yes, can I get your contacts from your shirt, for example, right now? Like this.
Yes, so if you ask me, when I joined the company 2 years ago and I came from marketing and fashion industries, I did not believe in this technology at all. And many of my clients and the contacts that I was hitting up did not believe in that as well. But now I'm seeing a huge change and a huge number of possibilities that this may bring. And sharing your socials through the NFC tags is just like an easy use, like that's mostly entertaining for the people. But imagine that you're organizing an event, like an event that is happening every single year, for example. So once you go to the event and you get a wristband that allows you to get there, and then when you you come there next year, then as an organizer you can gather all the data of the person, what they were doing at the festival and so on, because they had the NFC tag on the wristbands all the time. You can track when they were going, you can track who they are, you can gather a lot of information from that. So this is like just one kind of the thing that you can do with the NFC tag, and the possibilities, you know, I mentioned the events before, that you can have the ticket on your NFC tag. The possibilities are endless, and now, if you ask me personally, I fully believe that. And after we're done, you can also test it yourself, because we've prepared a merch for you, which is right there. So everybody that is on the VIP list could get a hoodie, a t-shirt, and a cap. And if you're not on the VIP list, everybody can just claim the cap or a t-shirt. So you could simply go to to Gabi and Philip right there, grab your own item, test it out yourself, tap the phone to the NFC tag and see what happens. Does anybody have any questions? Okay, I guess we're done. I hope you enjoyed it and hope to speak to you after the lecture as well.
Thank you, Anna. Yeah, so that's all we have for you in terms of content. I just wanted to take this chance to invite you to the ETHWarsaw conference that's going to take place in early September. We're gonna release the tickets soon, probably in the next week or two. We'll be also opening the call for speakers, so if you would like to present at ETHWarsaw, this is your chance. And for now, thank you so much for coming. Let's enjoy the drinks and pizza, which are in the back, and let's do some networking, and we'll see you next month.